Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So this is another video from the Strivers A to Z DSA course. Just in case you're for the first time here, this is world's most in-depth course in DS Algo. Why do I say that? Because this course has 455 modules. By the end of the course, you would have solved more than 400 plus problems when it comes to DS Algo. You can go across the entire internet. You can buy any of the paid courses. None of them will be teaching you DS Algo in such depth. One thing that I can assure you is once you complete the entire course, you can clear any of the DS Algo rounds in any of the companies in any part of the world. So till now, we have covered till stock buy and sell. And in this particular video, we will be covering the problem rearrange array elements by sign. Now, what does the problem state? You will be given an array with equal positive elements and equal negative elements. That means if the length of the array is n, there will be n by 2 positive elements and there will be n by 2 negative elements. That is for sure. That means n will always be an even number. N will always be an even number. So if I take this first example, over here you can see that n is 6. So there are 3. Yes, there are 3 positive numbers. If you see 3, 1 and 2, and there are 3 negative numbers, -2, -5, -4. Now, they can be given in any random order. Positive, positive, negative, negative, positive, negative, positive, negative, 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 positive, positive, doesn't matter. It can be given in any order. So your task is to rearrange those elements by sign. What do I mean by rearrange? First one has to be positive, then it has to be negative, then it has to be positive, then it has to be negative, positive and negative. So when I say positives, 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 let's write the positive 3, 1, 2. These are the 3 positives. And you have put them one here, and the other one here. So they are in the order 3, 1, 2. If you look at the order here, it's 3, 1 and 2. So the order is maintained, but they are making sure that they are alternate, like positive, negative, positive, negative. If you look at the negatives, -2, -5 and -4. Let's look at the order in the original array. -2, -5, -4. The order is maintained. But they're making sure they're in the alternate, like positive, negative, positive, negative. So your task is to solve this particular problem. So whenever this question is asked to you in an interview, the first solution that you should definitely tell the interviewer is the brute force. The first solution that strikes your head. That's very obvious. You'll be like, okay, listen, I'm going to take an empty array and I'll call it as positive array. I'll take an empty array and I'll call it as negative. Again, it can be an array, it can be a list. I'll prefer a list. You can also take an empty array because you know the size will be n by 2 and n by 2 because the number of positives are n by 2, the number of negatives are n by 2. But I'll prefer taking list. Now what I'll do is, I'll iterate in the entire array. It's 3. So I'll be like, put it into the positive. It's positive, put it into the positive. It's negative, put it into the negative. It's negative, put it into the negative. It's positive, put it into the positive. It's negative, put it into the negative. So I can say, once I've done the first iteration in the brute force, I have all the positives and I have all the negatives. So after one iteration, can I say that I have all the positive elements in the correct order and I also have all the negative elements in the correct order? If I go back and recall the rearranged array, it would look something like 3, -2, 1, -5, 2, -4. Now, if I ask you, in terms of indexes, where are the positive elements? It's like at the 0th index, at the 2nd index, at the 4th index. Do you see a pattern? Yes, you do. All these are even indexes. All these are even indexes. So all the positive elements appear to be at the even indexes. What about the negatives? They appear to be at the odd indexes. So I'll try to take an advantage of it. I know one thing. 3 will be at the 0th index. 1 will be at the 2nd index. 2 will be at the 4th index. And if I have to write down their particular index, it is like 0, 1, 2. Do you see a pattern? 0 belongs to 0. 1 belongs to 2. 2 belongs to 4. And the third index, if there was, would have belonged to 6. Yes, you have noticed the pattern. So what I'll do is, I'll be like I equal to 0, I lesser than n by 2 because I know there are n by 2 positive elements. Array of 2 into I because that is what index where it belongs to array. Because that is the index where it will go in the array. Equal to positive of I. Quite simple. Similarly for negative, this belongs to index 1, this to 3, this to what? Yes, 5. So can I say I'll write array of 2 into I plus 1. 2 into I plus 1 equal to negative of I. Quite simple. One more iteration and that is done. So I can say I did a single iteration of big O of n in order to pick up all the positives and negatives. Then I did another big O of n to reassign them to the array. Once this is done, the array will be rearranged. But I ended up taking a space complexity of big O of n in order to store them in order in two different arrays of n by 2 and n by 2 each size. So this will be the overall time complexity and space complexity. For solution is taking a couple of passes and it is using some extra space. The interviewer might ask you to optimize. Can we remove this extra space? I don't think we can, because somewhere we have to do something in order to find the answer or to store. We have to use some extra space. But can we reduce this 2 pass into 1 pass? That is where my focus will be. And that's where the optimal solution comes in. I'll be like, hey, listen, let's take an answer array. And what was the first observation? My first observation was, I know one thing. All the positive elements will be at the even index. So if I write down the index 0, 1, 2, 3, 4, 5, can I say all the positive elements will be, like the first positive element will be at the 0th index. The next one will be at the 2nd index. The next one will be at the 4th index. And can I say the first negative will be at the 1st index? I can. Now what I will try to do differently in order to do it in a one pass is, I will go to this 3 and I'll say, hey, you are 3. You're positive, right? So can you go to our first place, which was assigned for a positive? He's like, I can go. And then he'll be like, okay, you're gone. So what is the next possible place where you can put a positive? It's like this one. That's for sure, because the 0th index is occupied. Perfect, done. Next, it's again a positive. So which place is there? Is this 2nd index? Put it. And if you have put it, where will the next place, where is the next available place? That's at the 4th index, so you move. Next you move -2. It's like -2. Negative. First available place. This one. Put it. Once you put this, move to the next. What is the next? -5. Where do you put it? We know. It is a negative, so first available place. Put it. And then what do you do? Move it. Next. 2. Positive. First available place. Put it. And then move. What is the next? -4. So if it is -4, it goes to the first available negative place. Once you have done it, move. So once you've done it, it just took you one pass. You put that into the answer array and done. Yes, we are not rearranging in the original array. We know that. We are rearranging it in a new array and we will use this as the array that you will return. Got it? But this can be done in big O of n pass. While passing, keep on putting them into the answer array. And the space complexity is big O of n. Again, this is used to return the answer. This is used to return the answer. So this will be the time complexity and the space complexity. For the optimal approach, not a huge improvement from the better. Not much, by very slight margins. So coming back to the code editor, let's try to code it up. So you're given the nums. What I'll do is I'll initialize an answer and I'll keep the size as n. Let's quickly declare the size n as nums.size. And now let's quickly have a couple of other things. Positive index equal to 0. Negative index equal to 1, because that is where we start the first positive and negative from. And now let's quickly go across the entire array. And now we say, hey, listen, if nums of I is lesser than 0, that's a negative. Else it is assured that the array will never have zeros. So the answer of positive index will be nums of, or rather negative index will be nums of I, and negative index, the next one will be 2 places ahead, so you can do. And similarly in the else, what you can write is, if it's a positive one, we will put it into the positive and we will move the positive index by 2. Once we have done the entire thing, we can go ahead and say, this is my answer. Can we quickly go and return this? And I'll just click on the submit and see if it is running absolutely fine. Now this one is done, but we will be solving one more variety. So in Code Studio, the problem is saying it is having positive and negative, but there is no mention that they will be equally, like n by 2 and n by 2. If you read this line, if any of the positive and negative numbers are left add them at the end without altering the order. So if there is still something left, you have to add them at the end without altering the order. So how do we solve this particular variety? Let's look at the solution for this. Okay, so coming to the variety 2, let's take this particular example. So one thing we know for sure is, if positive is not equal to negative, there can be two cases. Either the number of positives are greater than negatives, or the number of negatives are greater than positive, right? That is something we know. Like for this one, we have 2 negatives and 4 positives. So the number of positives are greater than negatives. So what will be the answer after rearranging? Can I say the answer will be very simple? First I'll put up a positive, done. Then I'll put up a negative, done. Then I'll put up a next positive, done. Then I'll put up a next negative, done. And after that, whatever remaining, because positives were in excess, you just pick up the next positives, the next negative, next positive, and put it into your answer array. And this will be your final answer. So how do you solve this particular variety? That is what we have to figure out. So let's quickly solve the second variety of this problem. So the second variety of this problem is clearly stating you that we're not sure if positive is equal to negative. We are not sure about that. It can be more, it can be less, we're not sure. So we have already solved the case of positive equal to negative, right? And now this is stating that it might be, might not be. So if it is not, if positive is not equal to negative, what can it be? So there can be two cases. Yes, the number of positives are greater than negatives, or the number of negatives are greater than positives. There can only be two cases. Either the positives are more, either the negatives are more. So definitely, we cannot use the optimal solution, because the optimal solution was lying on the fact that we have same number of positives and negatives and we are filling them. We are filling them alternatively. So what we do is we fall back to the brute force solution. Now this is an amazing follow-up question. Why? Because a lot of times people think it will be something else. They do not fall back to the brute force. They're not confident about their initial solution. So you fall back to the brute force solution. And what you say is, since we know the positives are not equal to negatives, I will fall back to my brute force and I'll say, okay, I'll probably keep 2 more arrays, which is like positive array and a negative array. I'll iterate and I'll collect all the positives in their relative order. And I'll also collect all the negatives in their relative order. So let's quickly do this. Once you have done this, we know one thing for sure over here. The number of positives are greater than number of negatives. So there are 2 negatives. So can I say the first 4 elements will be in order, which is like 2, -1, 3, -3. They will be in the exact alternating order, because the number of negatives were 2 and which was lesser. So we are sure of having 2 positive. So 2 positive, 2 negative, 4 numbers, and they can be in the alternate order. So what is remaining? 2 positives are remaining. So after that you can put up the 2 positives. So something I know is, for the first 2 elements, I can follow the pattern. So what I will do is, for the first 2 elements, I will follow the same pattern. So I know one thing, for I equal to 0, and I know the number of negatives are smaller, so it is like I less than 2 in this case. And I will say, hey, array, I into 2, because for that was the brute force. If you remember, the brute force was I into 2 is equal to positive of I. And similarly, I'll say array of I into 2 plus 1, because for negative, it was that index. If you write down the indexes in the answers, it's like 0, 1, 2, 3. And these people will be filled, because there are 2 negatives and 2 positives for sure. And I'll say negative, can you pick up? Perfect. So this will make sure till the place the positives were equal to negatives, that is done. That is for sure. So he'll fall back to the brute force. But now we know one thing for sure. There are some more positives. Who have to be taken care of. Now, where are the positives starting in from? If there were 2 positives and 2 negatives which are placed in the correct order, it will start from the second index in the positive array. So let's start from the second index in the positive array. And it's very simple. And then I'll go till positive dot size I plus plus, and they will take place at which place in array? So can I say, if there are 2 negatives, 2 positive, they would have taken the first 4 places. So the place where I will start off is index 4. Index equal to positive I, and then I can go ahead and move index plus plus. Simple. So this is an extra addition of code that you have to do. Extra addition to fill the remaining values. I hope you've understood this. Okay, so coming back to the code editor, let's quickly code this up. So what do we know? We need to store positives and negatives. So we need 2 data structures, positive and negatives. Then what we know is we have to go through the entire array. So we need the size of the array. So let's take a.size. This will give me the size of the array. Now let's quickly iterate like this. Okay, I have iterated like this. What will be my next job? I'll say, okay, if array of I is greater than 0, it's a positive. Otherwise, it's a negative. And in this case, what I'll do is I'll say positive dot push back. Basically, I'll store it in the positive list array of I. Or else I will say negative dot push back a of I. So this will make sure we have the positives stored in the relative order in positive and the negatives stored in the relative order in negative. Now we know one thing. There can be 2 cases. If positive is greater than negative, right? Or else it can be the other case when negative is greater. And this will cover the equal to case as well when negatives are equal to positives. If this is the case, what will you do? We know negatives are the limited, guys. So we'll just go for those many negatives. We will just go for those many negatives. So let's go for those many negatives. And so if those many negatives are there, those many positives will also be there. So let's quickly go into the array and say, okay, in the even place, can you take the positive of I? And in the odd place, can you take the negative of I? Perfect. You remember this, we have already explained in the brute force solution. 2 into I will be the even and 2 into I plus 1 will be the odd. So this will make sure, so if the negatives are 2, 4 elements are done. 2 from negative, 2 from positive. How many positives are left in this example? This many. So you start from the second index in the positive array. What is 2? Size of the negative. Just take it. So you start from the negative dot size. And how long do you go? Till positive dot size. Because those many are left. And which index do you start? Yes, which index do you start on in the array? So can I say, if I'm taking 2 elements from here, and I'm taking the first 4, which is index 0, 1, 2, 3. So the index that I start is 4, which is nothing but the size of negative into 2. So I can say size of negative size, can you do 1 into 2? Perfect. And now what I'll do is, hey, array of index, can you take the positive of I, and after that can you move index plus plus? Quite simple. This will make sure this is done. And can I do the same thing for the else? I'll quickly do the same thing for the else as well. So in the else, can I say this? This will be opposite. So I'll just quickly copy paste this. Can I say this will be positive? I can. And the remaining elements, can I say it will be just the opposite, which is instead of this, it will be from here. This will be from negative, and this will always take from negative because this time it's the opposite. And if they're equal, this array will never execute. If they're equal, it will be done and dusted from here, and this will never get executed. Once you've done this, can you return the same array? Because in the same array, you did the changes. So you can return the same array. So I can quickly go and run this off and see if it is running fine. Should. Okay, go and I wrote a long code. Impressive. So let's discuss the time complexity for the second variety. Can I say I'm running a big O of n iteration to basically get all the positives and negatives. And then can I say I'm running a loop for minimum of the positives or negatives. We'll decode this afterwards. Yes, we are running that. And then can I say I'm running for leftovers. I'm running for the leftovers. Yes, I can. Now, if I have to decode this, let's decode the minimal value of this and the max value of this. We know this is for sure. First we run for minimums and then whatever are leftovers we run. So, what can be the minimum of this? Like, what can be the minimum time it runs? I say all are positives or I say all are negatives. So, either I say this is 0 or I say this is 0. There are no negatives or there are no positives. In that case, this one will become big O of 0. But the leftovers will be big O of n. Can I say this? There are still leftovers of big O of n because if there are no positives, I'll have to still put all the negatives by running a loop. what can be the max, like what can be the max of this guy? The max of this guy can be, this is n by 2. This is n by 2. Because imagine they're equally divided. Then the leftovers will be 0. So what I can say is, this particular thing has a worst complexity of big O of n when everything is positive or everything is negative. And this is for the first iteration. So this boils down to big O of 2n. Got it? And what about the space complexity? Big O of n. Why? Because you're storing all the positives and all the negatives. I hope you have understood. And going back to the first variety of the problem. In the first variety, I did say that the brute force solution is taking 2n. It is not. It's taking n plus n by 2 because the second loop we were running for n by 2 times. There's n plus n by 2. That was a typo from my end, but I hope you have understood, right? So this is how we can solve the second variety as well. So going back to the sheet, I can just see that this is done, and I hope you've understood everything. So just in case you have, please do consider giving me a like, because it won't cost you anything, but it will definitely motivate me to make more and more videos and to continue our tradition. Please do comment understood so that I understand that you're understanding everything. And if you haven't followed me on all social media handles, LinkedIn, Instagram, Twitter, all the links will be in the description. Do try out the problem from the problem link in the description. And here with this, I'll be wrapping up this video. Let's meet in some other video. Till then, bye-bye.